Absolutely, over 7 years, like we must have made 50 prototypes. My name is Greg Thrash. I'm a mechanical engineer for E13 Components.
My name is George Dubois. I'm Director of Engineering for E13.
We started working on this project, I believe, must have been 2017. And originally the project was aimed at developing a silent hub. That was the plan, is that it would just be quiet and have low drag. At the time we developed or actually just investigated a number of existing systems that were on the market. At the end of that process, we hadn't really identified anything that we could license or incorporate into our design that was great. So we kind of went down a path of designing our own system. That was kind of the first phase of this project, and I think that went on for a couple of years. At that point, we sort of had a concept, which was loosely the system that a bunch of the racers, pro riders were running over the last couple of years. Towards the middle of 2023, we had a pretty well-developed version of that hub that was working great, and especially on the downhill circuit, it was working really well for the racers there. What we found was that the system that we had was not ideal for a consumer, because the engagement, if you put it on a trail bike, you would have some pops or misengagements that happened while you were, as you were starting. Sometimes it would engage perfectly, sometimes not. George Dubois, our other engineer, spent a lot of time trying to dial in that engagement in the hub system that he had developed to that point.
It was a bit of a milestone that we couldn't get past. So we tried making the pusher flexible so that if it was in that spot where the pawl wasn't completely engaged with the ratchet, a little extra force would help the pusher flex and then find home. And that was a big improvement, but it still wasn't completely solving the problem. And then we started having problems with like the flexible engagement piece. Wasn't as robust as we really needed it to be. So we worked a lot on the material there, how this was sandwiched together, and we were able to get something that lasted a long time but didn't really have the final performance aspect that we wanted.
Yeah, I think another thing that was happening with those flexible pushers was that you could feel the pusher flexing through your pedals.
Yeah, that's correct.
Which was not a sensation that you're used to feeling when you're riding a bike. So even though that didn't have a negative performance impact in and of itself, it felt strange.
Yeah.
So from the point of view of, can you just give this to any person and have them ride it, it was an effect that was kind of a negative. So the first version of this design that I made that actually worked was something like this, where there's a 3D printed part mounted to a steel part, and then there's a spring that's acting as the stop. So the spring is indexing to the teeth and ratcheting inside the ratchet, and so it can only stop at certain positions, and I could actually just cut that up by hand. And on the bench it worked. And so I replaced the sprag clutch in the hub shell with just a bushing. And you put this thing together and you can make a hub that works. I was printing these and sending them out to everybody internally that had these hubs and was able to run them. And we already had the cutaway free hub body that was compatible, and so all of a sudden I've got a system that fits inside the envelope we've got. So there was some serendipity to that, where I had a concept and there was enough real estate available that I could make something that fit in the hub. And once we put all these things together, all of the hard work that had been going into the bearings and the Durab seals and the locations of all those features, all of a sudden we have good engagement and this hub works amazing. So since then, one of the things that happened was after we realized we were going to have to develop our own engagement system, we pretty quickly came up with a system where we were adding what we call deadband to the hub engagement mechanism, which means that as you start turning the pedals forward, there's a period of time where nothing is happening in the hub in terms of the pawls engaging with the ratchet.
And so we started playing with adjustment in there to see if we liked more or less. Like maybe that's a total of 16 degrees. Maybe that's a little too much for some people or some bikes. So we put some adjustment in there, and what we found was it really had an effect on the suspension. Running it wide open with like a greater degree of engagement really eliminated pedal kickback altogether. We got through that and really lots of iterations, constantly tweaking the geometry of how the pawl interfaces with the ratchet, how the pusher interacts with the pawl, bearing configurations to eliminate any sort of end play, working on all of the tolerances for fit and function tolerances, and really like doing some manufacturing studies on what we can achieve, what works, what doesn't work. So we tried a lot of different things, a lot of different versions of the pusher, assemblies that flexed, assemblies that didn't flex. And then finally, Greg came up with the idea of having the pusher timed to the ratchet ring. So it was a very precise engagement, and that really took off. We were able to make something that kind of satisfied everything we wanted out of this hub.
The system that we have now, that deadband, you can actually tune it for different bikes. One of the cool things about the current design is you have the ability to change that depending on. You could change it for every ride if you wanted to. It's pretty easy to do. For most people, you're going to find something that's comfortable for you and works in the area where you ride, and you're going to set it there and just never think about it again.
Our race team feedback has been really, really good. We gave out wheels that hadn't overcome the engagement issue we were talking about. And so those got sent back pretty quickly. They're like, yeah, we like it, but there's still this little thing that we're not sure about. So as we refine the engagement, the teams have been very happy. We focus a lot on pedal kickback because that's the most obvious one, but it really does cut down on drivetrain vibration. We've done some comparative testing with like high pivot bikes that should have the same net effect on pedal kickback, but the riding sensation is quite a bit different. And we have a person in our German office and then our product manager have been dealing directly with the teams, really hands-on in the last year, and like fine-tuning all of the final points. Like we've had like one part that fits into a bearing where we were using the race team feedback and just their accelerated wear, we were able to see like if we're just off by like 0.01 millimeter, like it wasn't working. So we had lots of part swapping going on in the pits, lots of late nights with our guy Sebastian. He really put in a tremendous effort getting the teams happy and then making sure that what we were narrowing in on was going to be the right solution.
Once we had sort of isolated the architecture that we wanted for the hub in terms of like the bearings go here and the ratchet goes here and the pusher goes here, then that really didn't change for a pretty long period of time. But it's, the devil is in the details. Like there was probably hundreds of changes over the last 2 years.
We've done some pretty exhaustive machine testing to find like the ultimate and fatigue limits of all the parts involved. We've got wheels that have been out for like a year and a half, 2 years with no issues. And then we have race teams that are still on the same bearings that replace, they'll clean it out, add a little grease between races, especially with the runs that require like pressure washing. But overall, the performance has been really high. We've been making other hubs for about 12 years now, and we've taken the parts that really worked well out of that, like the ratchet ring material, ratchet ring geometry, pawl material, and pawl manufacturing process is really top-notch, where those, they're really indestructible. We applied that to this project, and then where we had space constraints, we made sure that we doubled up on bearings. We made sure we were using the highest quality bearings we can get and made sure the clearances are correct.
And that's kind of the invention in a nutshell.